Good evening, one and all. In today's lecture, we are going to discuss about the topics dynamic method dispatch and abstract class abstract method, which is important to understand interfaces in Java. So consider an example, an illustration. Suppose you are asked to share your Google Drive files and folders with your friend. Okay, one of your friend needs access to your Google Drive files and folders. Now, he is saying that you give me your username, I mean your email ID and your password. So you'll give him your email ID and password, and then he'll access your Google Drive, and then he'll take the folders which he wants. But the risk is that he will also get access to your other Google handles like email, that is your Gmail. Then maybe he'll get to see the other files in your Google Drive, or he'll get to see the Google Maps and all your address information and all that, or your location and all, whatever information you have stored in your Google account, he may get to access it. So what you will do is he only wants the Google Drive. Okay, so you are only going to share that part of your details. To do this in Java, there is a similar concept like if you don't want to share everything, only a part of the data. That time you have to use dynamic method dispatch. For example, in case of inheritance, you have your base class and your derived class. So maybe the base class needs to share its details with the derived class. That time what you will do, you will not share all the methods of the base class, suppose. You will share only particular methods of the base class to the derived class. Okay, let that some examples we can have, wherein the base class wants to share only particular details, or the base class only wants particular details to be accessed by the derived class. So in that case, the creation of the object, there a little change is there. Till now, when we were creating objects, suppose we have a class called base, then we were writing base object name equal to new, then again base, and the parameters we can pass here if it is a parameterized constructor. Till now we were having base on the left hand side as well as on the right hand side. Now there will be a small difference. The base will be at the left hand side only, but here instead of this base, you must write derived. Now how it will affect the program, the logic and all that we will see. Okay, so this is the change. Left and right hand side, you have different class names. Base is a class, derived is a class. But on the left hand side, you will always have the parent, and on the right hand side you'll have the child. If you want to access only particular methods, if you want the derived class to access only particular methods, okay, that time we can use this. So let us see the program now. So when you do such a thing where parent is on the left hand side, object name, and new child is the derived class from the parent. So this is called as you are creating a reference of your parent. If you write parent obj means you're creating a reference of your parent. You have to read it like that. And if there is a child at the right hand side, you must say that the object creation is from the child. That means that you are saying that the reference is of the parent, but object creation is from the child. That is how it is read. And what is its meaning, we will see. So using this obj, you will be able to access all the methods of the parent. Why? Because whenever we, for example, if I say int a, then a is an integer. So all the properties of an integer are given to a variable. Similarly, if you say parent obj, everything of the parent is for the obj. So using obj, you can access everything of the parent. Okay, using obj, you can access everything of the parent. Means if it is public, if it is private, something is private inside the parent, then using obj, you cannot access it. But whatever is of the parent is possible to be accessed using obj, because it is an object of the parent. It is a creation of a reference of the parent. But the object creation is from the child means whatever methods you call, they will be of the parent definitely. Okay, it can access the parent's methods. And if there is any common method between the parent and the child, for example, in the parent also you have add method, in the child also you have an add method. When the method is common in parent as well as child, that means even the parameters are same. Add int a comma int b, In the parent, even in the child, add int x comma int y. Int that should match. Your parameter names can be anything. So if the exact same thing of the function header is there in the parent as well as the child, that is a case of overriding, right? Am I right? It is a case of overriding when you have the same method. Yes, it is overriding. So in such a case, we know that always the child version will get executed unless we use the super keyword. Always the child version of the common method will get executed. Child version means the method add which is defined inside the child class. Okay, so using object, what all you can access? You can access the parents methods as well as you can access the child class version of the common methods and even common variables and all. But if this object you are using to access the child classes methods, for example, in the child class you have another method, multiply. That method you cannot access from the this obj because it is a reference of the parent, and parent object cannot access the child entities. Okay, so using object, what all you can access? Parents, all the methods, and also you can access the common method, but the definition which will get executed, since the method is common, the definition which is in the child class that will get executed, but the other methods of the child which are not common, other methods of the child which are not common between parent and child, those methods which are not common you cannot access using obj. So this is what you're restricting some methods access. You're not allowing the person to access everything. Only what is common that you're giving access. So that is what I was talking about the Google account details. And when you're creating such objects where left hand side is parent, right hand side is child, in this case also, since it is inheritance concept, you will always call the parent class constructor first. Parent classes constructor gets called first always, and then the base classes constructor. Same like a normal inheritance in which you have parent obj equal to new parent, means left hand side also same class, right hand side also same class name. In such cases, it is your normal inheritance. That time we know that always the parent class constructor and then the child class constructor gets called. Similarly, in this case also, first of all, parent class constructor will get called and then the child class constructor. Is it clear till here?
Yes.
Okay. For example, your phone and your smartphone. Now, maybe your phone cannot access Google Maps, but your smartphone can access. Means not everything, or maybe only particular features. Okay, that I want to say. So, for example, in your phone, you have show time feature and you have on feature. On means you are starting your phone. Here in the smartphone also, you'll have that same on feature. You can start your smartphone. And maybe you can also play some music in your smartphone using your smartphone. But playing music is not possible with your normal phone. So first of all, you can create an object of the base class, that is phone. And using phone, you can access everything which is inside the phone class. Now, similarly, you can create an object of the derived class, smartphone object you can create. And using smartphone object, you can access show time on as well as play music and on. And answer my question that if you're creating an object of your smartphone, left hand side also smartphone, right hand side also smartphone, then here there is on function in the base, in the derived also there is on function. So which on function will get called?
The second one.
Yes, second one. Okay. You have seen this multiple times. Now, if I don't want to do these two things, what I have discussed now that we will do that, phone on the parent on the left hand side and child on the right hand side. So using this obj, as I mentioned, you can access the base class methods like show time and on. Okay. Derived class method play music, you cannot access. The on method of the derived class is common between phone and the smartphone. This on method is common to the parent as well as the child. So this common method you can access, and which definition? The base class, the child class definition. That is this part, this on function, not this one, the child class version of the common function method. So let us run this. So I have created an object of using dynamic dispatch method, dynamic method dispatch. Okay, this concept, this type of object creation is called dynamic method dispatch. And using this object, I can access show time because it is of the base class. And I can also try to access on, which is of the child class. But if I try to access play music, which is only in the derived class, play music is not there in the base class. So I cannot access play music. If I try to access it, you will get an error. It is highlighting in red color means error. So when I execute show time, it should means when I call it, it should print time is 8 a.m. And when I call on function, the second version, that is base, the child class version is turning on smartphone. These two outputs I should get. Let me run it. This is some other file which I need to, yeah. Now it will run. So if there is an error in any file of your package, then it may give a problem in running. So as I said, show time and on of the smartphone of the derived class, that on function is getting called. And you cannot call play music. So is this clear for everyone?
Yes, clear.
Yes, sir.
Okay.
Yes.
Yes. Okay. So this was about dynamic method dispatch. So the difference is here that whatever is not common in the derived class, that will not get called. Okay, whatever is not common in the derived class, that will not get called. Now another thing I didn't show you last time is the actual significance of this override annotation. See now, in your base class and in your derived class, in class A, which is base, and class B, which is derived, in A class you have meth2 method, and in B class also you have meth2 method. So if I don't give this override annotation, it's okay in this case, not much of a difference. But suppose in my derived class, I pass some parameters also, int a comma b. Then we know that whenever we create an object of derived class, always the meth2 of the derived class, that means this one will get called. But can you carefully see the function header, this part of in the base class, and meth2 function header in the derived class? Is this overloading or is it overriding? Overloading means parameters can be different. Overriding means everything should be same. So can you compare these function headers and tell me, is this a case of overloading or overriding?
Overloading.
Yes, because parameters are there in meth2 of the derived class, but in base class you don't have parameters. And we know that always when we call meth2 using B class object, this one will only get called. Now, if we want overriding in this case, means we want to restrict it. We do not want overloading. In that case, if I give this at override annotation, it will show me an error over here, as you can see. Because in overriding, everything has to be same. Only the definition, whatever is inside the curly bracket can be different. That means this part and this part should be same. To make it same, what you'll do here also, you can write some parameters, any two parameters. See, error has gone. Okay, or do one thing, remove these parameters. Then here also you will have to remove these parameters. Exact same it should be. See, again error has gone. So this override will allow it to override only. You cannot have any different definition over here. You cannot have any different function header over here. If you try to keep the function header a little different, then what will happen? It will give you an error if you are using override annotation. If you remove this annotation, no problem. Why we are writing override annotation? So that strictly overriding is implemented. Is this clear why we are giving this?
Yes.
Okay. Now another case we have seen when left hand side should always be parent and right hand side should be child. Now what if left hand side is child and right hand side is parent in inheritance at the time of creation of object? Now if you want to just read it in English, you will say that reference of the child and object creation is from the parent, right? You're creating a reference to the child and you're creating an object from the parent or of the parent. This is how you read it, okay? But this type of creation of object is not permitted. It is not allowed. It will give you an error, okay? So dynamic method dispatch always requires that left hand side should be parent and right hand side should be child. Is this clear? This case also? Yes?
Yes, clear.
Okay. Now the most important concept, abstract classes. Now, if you have any idea of this or if you have been introduced to this concept in C++ in college, you can just tell me, what do you know about abstract class or abstract base class? Or what do you mean by abstract? Any idea you have?
We have abstract data types.
Okay, actually, class name, whenever you write class name, for example, I write class base, suppose, and then I will define some things over here. So base that you say, that is your class name, is known as abstract data type. It is thought of as a data type. It is not means it is not data type. It is thought of as a data type. Abstract means something which you cannot actually see or which does not exist, something like that. It is just an idea, a thought process. So that is abstract data type. Class is an abstract data type, you can say. Okay, it is an abstract entity, but that is just a thought, like, but actually there is some meaning of abstract class. Anyone knows about that? Okay, no problem.
Hiding implementation.
Yes, idea implementation. So actually what happens in abstract class? In abstract class, it is a type of blueprint, or you can say skeleton, and the actual definition that you do inside your methods, that will not be there. Means you're only going to declare your function in the base class. If that is the case, it becomes an abstract base class. For example, I've written some points over here. Let us go through that first. Abstract class or abstract base class, both are the same. Now a class is called as abstract class if it contains at least one abstract method. Okay, so if you want to create an abstract class, you should first know what is abstract method. At least one means you can have one abstract method, two abstract method, three abstract methods, and so on. But minimum one you should have, then only it becomes abstract base class or abstract class. Now, if you want to make an abstract method, then you have to use an abstract keyword. So the order in which you write your function is what you usually write it like this: public or private, then the return type void, int, float, whatever, then the function name, and then you pass some parameters, and then you define your function, some lines you'll write inside, and you'll close it. So this is the normal way. This is called access modifier, return type, function name, optional parameters. Now you have to also add one more thing called as abstract. Now this method is called as abstract method. Okay, always abstract, you usually add it first and then the remaining. Okay, same thing I've written here. Similarly, that was abstract method. Now, when you create an abstract method, automatically the class will not become abstract. What I said, if you want to make your class as abstract, it should have at least one abstract method. So you have made your abstract method, but also you have to do one more thing. When you're writing your class name, that time you must write abstract class, whatever is your class name. Suppose fruits is your class name. And then you can write your methods, your data members and all that here inside your class. Okay, so first create this abstract method You don't have a definition for it, okay? So this definition won't come. Whenever your method is abstract, no, this definition part will not come. So if you don't put a definition, we know that we should terminate with a semicolon. Okay, this means what? You're declaring. How we declare variables int a semicolon. Similarly, instead of int data type, you have void return type. And instead of a as the variable name, you have function name as the function name and the parameters and semicolon. So this is called function declaration. And whenever you declare a function like this, if you want to make it abstract, you must write abstract over here. Now you have this abstract method. To make the class abstract, you must write abstract keyword here and then class name. And inside this abstract class, you will have all your methods and all that. And inside this abstract class, we know that at least one abstract method should be there. So this whole thing over here, I have to write it inside my abstract class here. And you know that we can have our different variables over here. Okay, so you have your variables and you have your abstract method. If you have an abstract method, at least one, you can have 1, 2, 3, how many ever, at least one. If minimum one is there, then make the class as abstract by writing abstract keyword. And not necessarily all the methods will be abstract. You may have non-abstract methods also. Non-abstract means your normal methods. Normal method means it will be all the methods that we have discussed till now. Like for example, get name method, you can define this method. Here also you can pass parameters. And this is not an abstract method, so you can define it. Means inside this function, you can write something. You can define the function get name, but you cannot define the abstract method. This is for the base class. This fruits class is a base class. And this base class is an abstract class. That is why abstract base class it is called. Okay, it is a base class, means future there will be derived classes. In future there will be derived classes, like apple will be a derived class of fruits, banana will be a derived class of fruits. So those derived classes I'll show you in the upcoming slides and all. But this is a base class, okay? Usually abstract classes are base classes. Otherwise you don't have much use of abstract class if it is not a base class. Okay, so abstract classes is a concept in inheritance. If you do not derive a class from abstract class, it is not of much use. Okay, so always usually, if it is an abstract class, it is the parent usually. And we have some derived classes derived from the abstract base class. So is this much clear for everyone?
Yes.
Should I repeat any part? Okay, so I'll show you examples. That time even more clear it will get. So this is the base class, whatever I have defined. Now some more points that we have to discuss. Also, another feature of abstract base class is you cannot create an object of this base class. Means if I say fruits obj equal to new fruits parenthesis, this is object creation of this base class, which is abstract. You cannot create because now it is an abstract class. Abstract class or abstract base class, same thing. So you cannot create an object of fruits class. You cannot create. That is why I'm saying that it should have its own derived class, because its derived class object you can create. Means since fruits is an abstract class, you cannot create its object. If you cannot create its object, how will you access its variables, data members, functions and all? If you do not create the object, you cannot access it, right? Do you agree with me? Without creating object, you cannot access the methods of fruits class. Am I right?
Yes.
Yes. So that is why, since it is abstract, we have to create its child, and its child ka object we can create, because its child may or may not be abstract. If child is not abstract, we can create its object, and through that object, we know that it is the child. So that using that object of the child, we can access the parents' methods also, right? If its child is not abstract, I will create an object of the child, and using that object of the child, I can access the methods of my parent. Am I right?
Yes.
Yes,
Yes.
sir.
Yes. So that is what we have to do now. Okay. And another thing, we just now saw that when we write, like this something like parent object name equal to new child. This is called dynamic method dispatch. Just now we saw it. So if it is an abstract class, this is possible. Why? Because here you're not creating an object of the parent. What I said, left hand side, how you have to read? You have to read it like you are creating a reference of the parent. It is not creating object of the parent. It is called as creating reference of the parent. How we know reference of the parent? Because here we are writing child. We are not writing the same class name parent. Okay, so left hand side parent, right hand side child means we are creating a reference of the parent. That is allowed, but you cannot create object of the parent. If I write here parent, is this allowed? Yes or no?
Allowed.
No.
Not allowed, because I just now said you cannot create object of the parent. This syntax is what? To create object of the parent class. And we know that parent is abstract in this case. Okay, means parent means fruits class. I'm just writing general parent. You cannot create object of parent, but you can create a reference of the parent. How? By writing the child class name over here. So that is another point that you need to remember. So these are the features of abstract class. Another feature, abstract classes can contain both abstract as well as non-abstract methods. I just now showed you. This is an abstract method, and that is why this class is abstract. But you can have your normal non-abstract methods as well. Okay. Now, abstract methods, you have to use abstract keyword, and they are only the declaration. They do not have their own definition. Right? Here we have only declared it. We have not defined it. So since we have not defined it, it is compulsory, okay? Always, it is compulsory to define this same method inside the child of fruits class. Means inside the derived class, this method has to be defined. It is compulsory in all the derived classes. Fruits class has how many derived classes? For example, apple, banana, orange, pineapple. So many derived classes of fruits classes possible. So all these derived classes have to compulsorily define this function, this abstract method. So let me give this a name, suppose get fruit. Suppose this is the abstract method, get fruit. So this get fruit method has to be defined compulsorily in all the cases, in all the derived classes. Okay, not that only 2 derived classes and the remaining no. All the derived classes of fruits class have to have the definition of this abstract method. But is it compulsory for all the derived classes to have the definition of get name method? Is it compulsory?
No.
No, because it is optional. Either if it has the same get name, then either it will be overloaded or overridden. If the same get name you have in your child class also, it is overriding. Or if parameters are different over here, maybe it is overloading. Okay, it's optional. You always will not have it. But if it is an abstract method, you always have to have it. And if always you have it, that means in the parent class you have the get fruit, and in the child class also you have the get fruit, then this is a case of overriding. So compulsory you will have overriding if the method is abstract. Do you agree with me? Did you understand? You will always have overriding if the method is abstract, because derived class will always have to define this get fruit method. So get fruit in the parent is also there, get fruit in the child is also there. And we know that this case is overriding. So if you have abstract methods, always you will have overriding. Is this statement correct?
Yes.
Yes. Okay. So there is so much of connection between all the concepts if you see carefully. Now, how you have to define this abstract method, I've already shown you. Abstract you have to write first, then public, private, protected, default, whichever access specifier. Then you can write static, or if it is not static, you will not write anything. Then you can write void, int, float, return type, whichever it is. And then you will write the name of the function. And then you'll give the parameters, which are optional. And as I said, it has to be defined. This same abstract method in the base has to be defined in all the derived classes. And if you are not defining, okay, there is an alternative. If you are not defining it, it is compulsory to define. But suppose you do not want to define, suppose that derived class doesn't want to define, then that derived class will again become an abstract class. For example, you have your fruits class over here. It has an abstract method, and so it is an abstract class. You have another class called as apple. And suppose this one is going to define the get fruit method. This is a derived class. So I will write here public void get fruit parameters. Exactly same you have to write. Only the abstract keyword, this will not come. You have to, everything else, that is public void get fruit, this is same. So I'll just copy paste it. So this will come in my apple class. And here I have only declared it, and it is compulsory to define it. So here I will define it. Here I will write something inside my curly brackets. So the criteria is satisfied that if it is a derived class, it has to implement that method. It has to define that method. But suppose I do not want to define this, then the alternative is I will make my derived class also as abstract. That means here also I will write abstract keyword. Is this clear? If I do not define my abstract method in the derived class, then derived class will also become abstract class. Is it correct? Did you understand?
Can you please
Yes.
repeat?
Okay, so I'm saying that we know that this get fruit function is abstract in the base class. So I said that it is compulsory to be defined in all the derived classes of the fruit class. So apple is a derived class of fruit class, banana is a derived class of fruit class. So in all such derived classes, this get fruit method has to be defined because it has only been declared in the base class. So in all the derived classes, I need to define it. So here I will write I will define it. And when you're defining, don't give the abstract word. This whole thing you have to give. This whole thing will be same without the abstract keyword. I will write it here. And here I will write my curly brackets. And inside this curly brackets, I can define the function, whatever may be. Suppose I want to print something. What is the name of the fruit that I'm going to print? So I have defined this abstract function in my derived class. But if I don't want to derive this, if I don't want to define it here in my derived class, which is compulsory, but I don't want to do it, still I don't want to do it, then what I'll do, I will make my derived class as also abstract. And once I make my derived class also abstract, base class also is abstract, derived class also I made abstract. Now it is not compulsory to define that get fruit method inside my derived class. Because since I didn't want to define that get fruit method inside my derived class, what I did, I made my derived class as abstract. So now I have made my derived class as abstract. So it is not compulsory for my derived class to have the definition of the abstract method. But you can still give it, but it is optional, not compulsory. If you do not make your derived class abstract, then it is compulsory. But once you make your derived class also abstract, it becomes optional to define that abstract method in your derived class apple. Now is it clear?
Yes.
Yes.
Others? Some more response?
Yes.
Yes.
Okay. Okay. So now tell me one thing. Is there any error in my program? I've told you everything, but still, is there any error? Can you detect? I have missed something.
Extends keyword.
Yes, correct. Very good. Okay, that I have not written. Otherwise, how will we come to know which class is extending which class, which is the derived, which is the base? Okay, so extends fruits, and since this is abstract, not compulsory to define the get fruit method over here. Now, another case. So I have not defined my get fruit method in the derived class. Now I'm going to create another class, say grandchild. This is called as grandchild class. Okay, and this is a child of the fruits class, of the apple class. So what I've done, fruits, from that I have got the apple, and from that I have got grandchild class. So this is which type of inheritance, do you remember?
Multi-level.
Yes, multi-level. So here also I have defined this grandchild. Now here I have not defined that abstract method. What was the abstract method? Get fruit. I have not defined. So here also there is a possibility that I will define it. So here maybe I will define it. Here I will define. Now if I'm defining the abstract method over here, if I'm defining the abstract method here, and it is of the grandparent class, the fruits class, this is also possible because derived class did not define the abstract method. So the grandchild, that means the next derived, is going to define it. This is possible. Okay, so if you are having such chain of inheritance, the abstract method in the grandparent, it can be defined in the grandchild, and it is not, if it is not defined in the derived, then also it's okay. So that means here in the apple, that is the parent, I did not define. In the grandchild I defined it. Okay, it has been defined. So should I write abstract keyword over here? Should I write it over here, abstract? No, because the abstract method I have defined it. Suppose here also I do not define that abstract method. Here also I'm not going to define it. Then I have to write abstract keyword here, right? Because we know that if the child or the descendant means grandchild, great grandchild, great great grandchild. Okay, so if the descendant is not going to define it, then abstract over here. But there's one more possibility that suppose I define that method over here. Here I'm going to define that abstract method in the parent. Then it stops. Like here it is not applying here now. Okay, means here what was the case? I did not define it in my parent. That is why I had a chance to define it in the grandchild over here in the third level. But if I define it in my parent itself, that is the immediate derived class, then it is not compulsory to go forward in the defining. Here it is defined, okay, story is over. No need to again define it here or anything, optional. But here if I don't define, it becomes compulsory to get defined in the grandchild. Now maybe in the grandchild also I don't want to define that abstract method. Then what I will have to do? Yes, here also I don't want to define that abstract method. Then what I'll have to do?
Write abstract before class.
Yes, here I'll have to write abstract. Okay. So till now I have not defined my abstract method, which is the get fruit method. Till now I have not defined. Wherever it was a chance, what I did, I kept on making that base class, the derived class, the next derived, I kept on making it abstract. Now maybe I have the next, that is great grandchild, the great grandchild class. Now here again I have a chance where I can define that method, the abstract method. So here if I define it, here I am going to define it. So now over, story is over. Further, if you have a great great grandchild, then it is optional to define or not define. But again, in my great grandchild, if I forget to define or if I don't want to define it, again I will make that great grandchild as abstract. And then in my great great grandchild, I have a chance to make it as the definition. Here also, if I don't, again I have to make this abstract. So it will continue and it will stop once you define it. Is the idea clear? Once you define it, you can stop. Otherwise, till then you have to keep on making all the derived classes as abstract. Is it clear?
Yes.
Yes.
Okay. Okay. Now there's one more possibility. Okay, so just now what we saw is we are going and trying to get a chance in the descendants, right? In the great 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 grandchilds, we are going so that there maybe we can define. So once you define it, you can stop. Means at least one of the descendants should have it. And once it has, you can stop, at least one. Maybe more than one also. Maybe in the great grandchild and in the great great grandchild also I have defined it. In two derived classes and two descendants I have defined. That is also okay. But minimum one, at least one. And if you don't do it, means in at least one also you have not done, then what? All the classes still now are abstract only, right? If I do not define it at all, not even in a single descendant, then all the classes still there will be abstract only. Am I right?
Yes.
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 So if all the classes are abstract, can I create an object of any of these classes? Yes or no?
No.
No. Okay. So that is the thing here. That is the problem. That is why I said that compulsory in at least one of the descendants you should define. Otherwise, there's no use of doing all this. You cannot create the object. How will you access the methods? That is why it is compulsory, or it is more useful. If you still do not define it, all the classes are abstract, it will not give you any errors. Okay. Your program will be error free. There'll be no errors in your program. But what is the use? You cannot access anything because objective cannot create. That is why uh, you have to define in at least one of the descendants. Okay, so these were so many characteristics of the abstract method and abstract class. So there's a program also over here. Where you have parent 2, then you have child 2, which is a child of the parent 2. Then you have another child, which is a child of the child 2. Means here same thing, grandparent, parent, grandchild. Right? You have the parent 2, from that you have the child 2, from child 2 you have child. Now, I also said that okay, I'll draw one case and show you. Just wait for the whiteboard to load. So you have a base class over here. And from this you have number of derived classes. These are all your immediate derived, means the direct children, not they are descendants also, but they are the direct children of the parent. Right? These are the direct children, first level. These are descendants also as well as the direct children. Now, one of these classes has further children. And this one also has further children. And further also you can have it, okay? Now, this is the abstract class. This is an abstract class or abstract base class, same thing. Now in all the derived, I will have to have the definition of the abstract method, right? Why do I say this is an abstract class? Because it has an abstract method. If it has an abstract method inside it, then only it becomes abstract class or abstract base class. So this is one branch, this is second branch, this is third branch, and this is fourth branch. In all these branches, at least one descendant. All these are descendants. Here you have only one descendant. In the branch number 1, you have one descendant. In the branch number 2, you have how many descendants? 3 descendants. In branch number 3, you have one descendant. Maybe in branch number 4, you have 2 descendants. Okay. Now in branch 1, there is only one chance to define the abstract method, right? Only here you have one chance to define the abstract method. If you don't want to define it here, what you'll do, you'll make this class as also abstract. Do you agree with me?
Yes.
Yes.
Yes,
Yes.
sir.
Now see branch 2. You have 3 possible choices to define the abstract method. Either you will do it here, or if you don't want to do it here, what you'll do, this you'll also make abstract. Then you'll go to the next level. Here you may define it. Then it becomes optional. But suppose here also you don't want to define, this also will become abstract. Then you'll define it here and your choices are over. Now in branch number 3, again you have a single choice. Either define it or make this also as abstract. Now in branch number 4, again you have two choices. Either define it here and then further it will become optional to define, or you make this as abstract and then you'll define it here, or maybe here also you'll make it abstract and then all your choices are over. So this particular branch becomes useless because everything is abstract here. Am I right? This particular branch, everything is abstract, so this branch is useless, right?
Yes, sir.
Yes. Means for now, for how many concepts we know, it is useless. Okay, so this is one more case wherein there may be different derived class chains. There is a chain of derived classes. Okay, now same thing has been done here. So if I draw the diagram for this, you have a parent2 class. From this parent2 class, you have a child2 class. I'll just write C. Okay, let me write child2 class. Then you have a child class which is coming out from child2. And then you have a child3 class, which is a direct child of the parent2 class. So again, here you have the choices in branch number 1. And in branch number 2, just one choice. So same thing is done here, that which is the abstract method in the parent2, the main base class. It is abstract, so it has an abstract method greet. Now, in the child2, which is the direct child, I have defined it. So it is optional to make this as abstract class. Am I right? Here I have defined that abstract method. So it is optional to make this class as abstract. Am I right?
Yes.
Yes. Now see, there's one more case. Yes, okay. There's one more case. This child2 can have its own abstract method. Right. This is a derived class, so it will define the greet method, which is an abstract method of its parent. But this child can also have an abstract method. For example, abstract public int my ABS. I'll write over here. Okay. And this is an abstract method. Now we know that if there is an abstract method in any class, that class has to be an abstract class. Am I right?
Yes.
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 That is why you're getting this error over
Yes.
here now. Okay, that is why you must remove this error by writing abstract here. See, error has gone because this class is also having abstract method. So this has to be an abstract class. Now it is compulsory to make it abstract. Whether you define it as greet, whether you define the greet method here or you don't define, this has to be an abstract class because it itself has an abstract method. Do you agree with me?
Yes.
Yes, sir.
Yes. Okay, so this is where the derived class will be compulsorily an abstract class. It doesn't depend whether you're defining that method or you're not defining the parent greet. Okay. Now rest of the things are same things which I've explained till now. You once go through this program. Okay. And I also told you that now we know that child 2 is a direct child of parent 2. And now see here, since just now I made child2 as an abstract class because I added this abstract method, I cannot create an object of this child2 class. Okay, but if this child2 class was not abstract, assume that it is not abstract, then what? I will use the dynamic method dispatch concept and I will write parent2 obj equal to new child2. Right, left hand side we can have an abstract class equal to its child. That means this concept over here. This is possible, this thing. But once I make my child2 class as abstract, we know that if the right hand side I'm writing something, it means that object is created using child2 or of child2. Object is created of child2. But child2 is abstract, so I cannot create object of child2. That is why now we are getting this error over here. Is it understood?
Yes, sir.
Yes.
Yes. Okay. So you just try to go through this program. For now, I'll just copy paste it in the chat box. You copy it from there before the meeting ends and just paste it in your Java IDE and then try to work with it. Okay. It is whatever I've discussed now theoretically without taking the program, that same things will apply. Okay. Just once go through it. Any doubts you can ask. Oh, there's a limitation to copy paste in your chat box. Okay. I'll send it on the WhatsApp group, that program. Okay. Try to go through that program. Any doubts you can ask me now. We'll stop here for today. And this concept that you learned today about abstract classes, abstract method, that will help you to create an interface. Now remember that an interface is nothing but it is similar to a class, but that class, you will call it as interface only if all its methods are abstract. In class, what is the case? You can have abstract methods as well as non-abstract normal methods. But in interfaces, all the methods are abstract. If all the methods are abstract, you have to call it as an interface. Okay, that we'll see next time. Any doubts? Any doubts from your assignment or any other doubts? College related doubts? Anything you want to ask, you can ask me. If not, you can leave this meeting. Thank you.
Thank you.
Welcome.
Thank you.
Welcome.
Thank you, sir.
Welcome.